Assalamu alaikum wa rahmatullahi wa barakatuhu. I'm Sir Rifat Ali. Now this time in front of you with the topic measurement. Okay, in the topic of measurement today we will discuss about units. Okay, in physics, what is a unit? Now first of all physical quantities need different types of basic things. For example, we can mention a physical quantity with a magnitude, proper unit, and sometime with a specific direction for some quantities. It means there are three basic elements for the measurement. One is magnitude, one is proper unit, and one is direction. So we divide all physical quantities into two groups. One that is completely described with the help of direction. So there are two groups. One group that requires only magnitude and proper unit and no need of any type of direction, like time, age, distance, speed, work. So these quantities do not acquire any type of direction. So we can completely describe by just mentioning magnitude and proper unit. Okay, now on the other hand, there are some quantities like force, acceleration, velocity, displacement, momentum. All these quantities acquire direction, specific direction for their complete description. Okay, I kick a ball, I hit a ball. In which direction it will move? First of all, in which direction the force is applied. Then we'll decide in which direction it will move. So direction is essential, compulsory. But one thing is common for all type of physical quantities, either scalars, those do not acquire direction, or vectors acquire direction for complete description. So both type of groups, all physical quantities acquire magnitude along with proper unit. So we are going to start our topic with the word unit. So what is the unit? Okay, if I say I need 1 dozen milk. 1 dozen milk? No, milk will be measured in liters or kilograms. Okay, I need 1 liter banana, 1 liter mangoes, or 1 liter apples. How you feel? This is not possible. The apples, bananas, and oranges we will measure in kilograms or per dozen. So proper unit is essential for different types of physical quantities. Okay, now unit, the least measurement in any system is called unit. So about unit, the least measurement, the least measurement of a physical quantity in a system of units, or just in a specific system or in a system, the least measurement of a physical quantity in a system is called unit. Okay, there are different system of units. Okay, the first system of unit is the British engineering system of unit, and the name is FPS, foot pound second. So this is British engineering system. Okay, but before starting different types of units, before starting discussion on different types of units, we have to decide for all physical quantities there are two different categories of units. One is a part of system of unit, okay, and one for different units for different physical quantities which are not mentioned in a system of unit, but we calculate it. Okay, so there are two different groups. Number one, fundamental or base units. Okay, the second one is derived units. Okay, The second one is derived units. Okay, now fundamental or base units for fundamental quantities. For fundamental or base quantities. So those units which are assigned for fundamental or base quantities are fundamental or base units. Okay, second one, the fundamental units are free from any type of calculation. So these units free from any type of calculation. Free from calculations. Okay, now the third one, we people are unable to assign or decide a fundamental unit for any physical quantity or fundamental quantity. So these units are assigned only by scientists. So these units assigned by scientists. Okay, fundamental or base units are for fundamental or base quantities. Fundamental or base units are free from any type of calculation. Fundamental or base units are assigned by scientists. Okay, now these units are also assigned by scientists, but there is a quality that sometimes we use Newton, and we can also use, rather than Newton, we can use meter per second square into kilograms. So kg meter per second square is also equivalent to Newton. So if you write down kg meter per second square, it's okay. If you write down Newton, it's okay. But the kg meter per second square, we did it ourselves. Okay. So these units are also assigned by scientists. But the main difference between these two type of units, the drive units assigned for drive physical quantities. These four fundamental or base quantities, these four drive quantities. Now these units are calculated by the simple process of multiplication and division, or multiplication or division. So these are free from any type of calculation, but drive units are obtained through simple process of multiplication or division. So drive, meaning to say these are derived from fundamental. So drive units are obtained through simple calculation of fundamental units. So after making simple calculation of fundamental units, we drive units. So drive units for drive quantities, drive units are obtained through simple calculation of fundamental units. Simple calculation of fundamental or base units. Okay, now in any system of unit, we only mention fundamental or base units, and in this system we use different fundamental units to drive units for drive quantities. Okay, now we will discuss different system of units. Okay, one of them is British engineering system, which never be international system. The British engineering system of units, the first system of unit, British engineering system. So British engineering system of units. Okay, there is a little history now about units, so we have to discuss, right? So British engineering system of units, FPS. F stands for foot for length. Okay, P stand for pound. LB, the symbol is LB. Okay, pound for mass. But listen, there is no fundamental quantities like mass. Okay, so pound initially for force. We use pound for force, but there is a relation between kilograms and pounds, equivalency between these two numbers. So we can consider pound for mass, but basically the pound is for force and the unit arc for mass. So mass is not the fundamental quantity in British engineering system of units, but in other system of unit which are international, the mass is the fundamental quantity. So over here pound for mass or weight. So weight is the force. So you can write down over here for force and later on we use it for mass. Okay, now the third one is second. It is for time. It is for time. So the fundamental quantities in British engineering system of units: length, force, and time. Okay, this was not the international system of unit. It's only for British, generated by British engineering system. Okay. Now we'll talk about international system of units. So the first international system of unit is CGS. CGS system of units. Okay, CGS system of units. Okay, C stands for centimeter for length, G for grams for mass, S for second for time. Okay, in CGS system of units, C stands for centimeter for the measurement of length, G stands for gram for the measurement of mass, and S stands for second for the measurement of time. Okay, now at this stage we need some more units that measure larger quantities. For example, if we are going to measure length of the boundary of a countryside area, so centimeter is a very small quantity. We are going to measure the mass of an elephant, or mass of an aeroplane, or mass of a car. The gram is the smaller unit. So a larger number we have to mention for such type of units. Okay, now after it there is a system of unit known as metric system of unit. Metric, MKS, system of units. Okay, now the same three basic fundamental quantities are used over here. Three fundamental: length, mass, and time. But M stands for meter, K for kilogram, and S for second. So we use over here meter for mass, meter for length, kilograms, small k, small g, for the measurement of mass, and S stands for second for the measurement of time. So in metric system of unit, or MKS, it is also an international system of units. So in this system we use meter for length, kilogram for mass, and second for time. So MKS system of units. But in 1960-63, in between 60 and 63, scientists decided to increase some more physical, some more fundamental or the base quantities. So there are three fundamental quantities in both the system: length, mass, and time. Length, mass, and time. So these three are the fundamental quantities for which we assign units known as fundamental or base units. Okay, now the latest system of unit is SI system of units, system international units. Okay, so presently we work on SI system of units. system international units. System international units, there are 7 fundamental quantities. There are 7 fundamental quantities. And what are these 7 fundamental quantities? So already we have 3 fundamental quantities, that are length, mass, time. So these 3 previously used in CGS system and metric MK system. So in SI units of system, these 3 is still the part of system international units or different international units. Okay, after length, mass and time, we use further thermodynamic temperature, thermodynamic temperature, okay, electric current, okay, 1 2 3 4 5. Next one is amount of substance, amount of substance, okay, amount of substance, amount of substance. And then last one, light intensity, light intensity. So these are the 7, 1 2 3 4 5 6 and 7. So in SI units, system international units, there are 7 fundamental or the base quantities. These are the fundamental quantities: length, mass, time, thermodynamic temperature, electric current, amount of substance, light intensity. Okay, for length, still we have meter, small m. Okay, for mass, we have the same unit, kilogram, small k, small g. For time, we have the same unit, second, small s. For thermodynamic temperature, okay, the unit of temperature, we use degree Celsius and degree Fahrenheit. Okay, this is the unit of temperature, degree Celsius, degree Fahrenheit, for the measurement of temperature. As the temperature is the degree of hotness or degree of coldness, so we use degree. The word degree is used for centigrade, Celsius measurement, and Fahrenheit. But the latest definition of temperature, it is the average kinetic energy of particles, molecules in a system. Then the unit of temperature we use as thermodynamic temperature, as a physical fundamental quantity, thermodynamic temperature, and we use for it Kelvin. As the relation between volume and temperature is not the direct relation, as it never passes through origin. So in the chapter of variation, we know that, or in case of direct proportionality, always there is a straight line passing through origin. So just to pass through the origin, we use, or we establish a new fundamental unit for temperature in terms of thermodynamic temperature, that is Kelvin. Okay, Kelvin, capital K. For the measurement of thermodynamic temperature for ideal gases or different substance, we use Kelvin. That would be equal to, after adding 273 in the degree Celsius unit. Okay, so when we add 273 degrees Celsius in the temperature mentioned in degree Celsius, so we have a thermodynamic temperature in Kelvin. Okay, there is a story, inshallah we will discuss in the chapter of thermodynamics. Okay, now electric current, the unit for electric current is ampere. Okay, and we use capital A for it. Amount of substance, okay, for amount of substance we use mole, M-O-L-E, mole. Okay, mole is something that we use in a relation generated by Avogadro. There is a relation, there is a direct relation between volume and amount of substance. Okay, so the amount of substance we use mole, M-O-L-E, but M-O-L as an abbreviation of mole, just like ampere Kelvin, second, kilogram, and meter. So MOL, mole, for the amount of substance. And for light intensity, the similarness of light intensity is candela. We use CD, small c, small d, candela. So these are the 7 fundamental or base units assigned by the scientists after 1960. So with the name SI units, System International Units, and these are the fundamental units. These are fundamental quantities assigned by the scientists. Okay, now by the process of simple multiplication and division, we can find out or drive quantities. Okay, after it, what these are the fundamental units, part of a system, SI units. Okay, now what are the drive units in the same system of units? Suppose we are talking about area. So area is 2-dimensional, we can touch it. And if we talk about volume, so we can hold it. So volume is something that we can hold it. Meaning to say, volume is 3-dimensional, area 2-dimensional, length 1-dimensional. So if we use for length meter, for area, that is 2-dimensional, length into breadth. So meter multiplied by meter, we have square meter. So this is the drive units. It is obtained by the process of multiplication, simple multiplication. Okay, we are talking about volume. Okay, length in meter, breadth in meter, and height or thickness in meter. Then we have meter cube. It is also a drive unit for drive quantity. Volume. Are we talking about density? Okay, density is the ratio between mass and volume. So the quantity of matter present in a unit volume is called density. So simply density equal to mass upon volume. Okay, the fundamental unit, mass is the fundamental quantity, so unit of fundamental quantity is kilograms. And for volume, that is the drive, meter cube. So kilogram per meter cube by the process of multiplication over here and division over here. The simple process of multiplication division, we obtain drive quantity, drive units. Okay, if we are talking about force, okay, now force equal to the product of mass and acceleration. Acceleration is change in velocity in a unit time. So we can write down for mass kilograms, for acceleration meter per second square. So in exam we can write down kilograms meter per second square. Okay, no deduction of score, but the kilogram meter per second square assigned by the scientist as Newton. So 1 Newton is that amount of force which has an ability to displace 1 kg object over the speed 1 meter per second square, or with an acceleration 1 meter per second square. This is Newton. This is the drive quantity assigned and also generated by the scientist. Okay, assigned by the scientist, the Newton, kilogram meter per second square. So all drive quantities have drive units which are obtained by the simple process of multiplication and division. Okay, now if there is a need of larger quantity, larger physical quantity, once again we are going to measure the distance of a boundary of a country, or we're going to measure the mass of a truck, or a huge amount of force required for hovering a helicopter or moving an aeroplane in a specific direction. We need some bigger units, but rather than change of units, fundamental quantities in SI unit system, or we introduce some prefixes which are used before a physical quantity. Now, what is the difference between physical prefixes and the original fundamental units for length, mass, time, and etc. Okay, inshallah, next time we will discuss conversion of units and for prefixes. Some of the example I am given over here. For example, we are talking about some smaller unit, smaller than 10. Okay, so deci. Deci comes from decade, 1/10 centi, comes from century, 100, or talking about milli from millennium, 1000. So greater than 10 we use deca, 10 times hecto, 100 times kilo, 1000 times. So a list of unit you can observe at the end of my this lecture. So after it I will show the list of unit in IB system or different boards up to a different level. Okay, inshallah, I hope that you will like this video. So please subscribe my channel, like and share. Allah Hafiz.